radicals, yeah. Cool. Uh-huh. All right. Now y'all dressed up. Pilgrims. That's unique. I like it. I like it. Yeah, yeah. Yeah, I saw him earlier. It was cool. Okay. So today we're working on simplifying radicals expressions involving binomials. So binomials means two terms. And so you can see here, this is at the very, very bottom, we're looking at here, number 14. All the same operations still apply, but we're going to involve distributing today. And so this becomes radical 3 times radical 6. What is radical 3 times radical 6? Radical 18 minus radical 3 times radical 24, which is radical, I don't know, we're just multiplying. 3 times 24 is 72. There it is, 72. Okay, and so I'm distributing, multiplying my radicals together, and then I need to simplify, and of course radical 18 is 9 times 2. What is my square root of 9? 3. So a 3 escapes. The radical 2 stays behind. 72. Ooh, that's a good one. 36 times 2 is how we get 72 using perfect squares. And what is the square root of 36? 6. So a 6 escapes.
Wait, is it supposed to be 22 or 24? Sorry, I'm confused.
This is 72?
72.
Yeah, 3 times 24 is 72.
I was like looking at you thinking it was like a 22. I'm like, oh, 22.
All right. So 6 pops out, the 2 stays behind. 3 radical 2s minus 6 radical 2s equals? Negative 3 radical 2s. All right. So radicals, we just got to break them down, finding those large perfect squares. All right, Kai, if you want to take a picture later, you can. You can also watch the video online for the ones you missed while you were sleeping yesterday. All right. Here we have a binomial times a binomial. How do you suppose we have to multiply these together? You could use the box method if you want to. I am just going to FOIL because that's what I do when I have binomials. But yes, I am going to FOIL. I would use the box method if I had like a binomial times a trinomial or a trinomial times trinomial. But FOIL, we're just distributing, so that's all we're doing here. What is 5 times 7 radical 2?
35.
35 radical 2 is correct. So when we're multiplying, regular 5 multiplies with regular 7 to get 35. And radical 2 is on the end. All right, we have 5 times 1, which is 5. And we are going to then distribute the negative radical 2 to both terms. So what is negative radical 2 times 7 radical 2? So, okay, yeah, I'm gonna leave it like that. Negative 7 radical 4. So again, a radical number can multiply together with a radical number. But then, of course, radical 4 can clean up, can't it? What is the square root of 4? 2. So I'm going to take care of that on the next step. What is negative radical 2 times 1? Negative 1 radical 2, yeah. All right. So I know that I can clean this thing up because the square root of 4 is really just 2. All right. So I have 35 radical 2 plus 5. That is really a 2. So negative 7 times 2 is negative 14. So negative 14 minus 1 radical 2. All right, so typically we write regular things first and more complicated things at the end. I don't know how you do it. It doesn't matter, really. 35 radical 2s minus 1 radical 2 would be 34 radical 2s. And then positive 5 and negative 14 give me negative 9. Beautiful. What you do want to be careful of is that this radical stops after the 2. You wouldn't want to get sloppy and do 34 radical 2 minus 9. Like, you don't want to, that's no good, right? That says something very different.
Is that how you do it? Like, roll it down?
So yeah, so that is the tail on a radical. You don't see it too often, but that's how you end it if you needed to. Yeah, that'd be super clear. What do we need to do for number 16? Multiply it by itself. Repeat it 2 times. Repeat that 2 times. So we have 7 minus 2 radical 3, and then times another 7 minus 2 radical 3. And once again, we're going to FOIL. So first times first. 7 times 7 is 49. And then we have 7 times negative 2 radical 3. Negative 14 radical 3s. Very good. Again, the regular numbers multiply together. Then we're going to distribute in the negative 2 root 3 to both items there. What is negative 2 root 3 times 7? Negative 14 root 3. Very good. And then negative 2 root 3 times negative 2 root 3 would be plus 4 root 9. Good. Which again, that cleans up, doesn't it? Yeah, radical 9 is a perfect square there. So, and again, the regular numbers multiply. Negative 2 times negative 2 gives us a positive 4. Radical 3 times radical 3 becomes radical 9. Got to keep with your like kind, really, is what that becomes. All right, so I have a couple of negative 14 root 3s. What does that give me? Negative 28 root 3s. And then that 4 root 9 becomes 4 times 3 because the square root of 9 is 3. So that's really 12. So then what is our 49 and 12? That gives me 61. So positive 61. Any questions on those? Easy, yeah? Okie dokie. Let's look down here. 23 and 24. These are particular. Oh, this is all we're doing. I'm doing rational exponents tomorrow. Look at that. There's the heading for 111. Oh, score.
We're only doing that.
So 23 and 24. Sweet. Okay. 23 and 24. These are, in particular, you need to know how to simplify these quotients that have a binomial denominator. That's what that says there. I didn't even read that. The binomial denominator, multiply the numerator and denominator by the conjugate are the directions here. By the conjugate. This is absolutely essential for you to know how to do really, really well, because this is the first thing we learn in calculus. And it's an algebra skill. Again, the goal is that we don't like to have radicals in the denominator. Admittedly, I will tell you it's kind of an antiquated rule because we have calculators, and I can totally put a radical in the denominator and get an approximation, right? I can do that with my calculator. But once upon a time, trying to figure out the value of something before calculators, BC. Sorry. I know. Okay. To have a radical in the denominator, no one wanted to take 72 and divide it by radical 5 to get the value because it was way too complicated. Okay, so they had to rationalize to get that radical up top, and then you could actually find the answer more easily, okay, because that was BC, before calculators, all right? So, what is a conjugate? What is a conjugate in Spanish or French?
Like a similar.
Well, so you're answering my question with mathematics, yes. The conjugate, to conjugate a verb is to change the endings, right? To conjugate a verb, you change the endings to get the proper, like he, she, it, they, we, whatever. We said, she said, sort of thing. So you're changing those endings, yeah? So we're kind of doing the same thing here. To take the conjugate is to change one sign. And what we're going to do, the conjugate is going to change the middle sign. We don't change everything, we just change one sign, okay? So we're going to multiply top and bottom by the conjugate, which in this case is going to be -1 plus radical 5 on top and bottom. And you'll see why that works nicely in a minute when we multiply it all together. So that is the conjugate, to change one sign in the middle. And then we're going to go ahead and just multiply it together. Why did I have to do it to top and bottom?
Whatever you do,
It's like 1. It's essentially, all we're doing is multiplying by 1. -1 radical 5 over -1 radical 5 is 1. It just simplifies to 1. So I'm not changing, we're manipulating. And that's your goal in this class, is how do you manipulate the algebra? We want to get really good at manipulation. All right. My youngest is really good at manipulation already, but this is a different kind of manipulation. All right. No, I have a younger daughter.
Wait, really?
Uh-huh. Yeah.
What's her name?
Caitlin. Katie. Yeah. She's the little blonde. She's bigger than Billy now, but yeah, she's the youngest. One day Billy will grow. Okay. One day. All right. We're going to go ahead and distribute the 4. What do you get when you distribute the 4?
-1 plus.
-4 plus 4 root 5. 4 radical 5. Good. And then in the denominator, we need to FOIL. So we're going to FOIL the denominator. I'm going to distribute the -1. Yep, -1 times -1 is 1. -1 radical 5, good. And then we're going to distribute in the negative root 5. So negative root 5 times -1 gives us positive root 5, positive 1 root 5 if you want. And then negative radical 5 times positive radical 5 is negative radical 25, yeah. Again, radical 5 times radical 5 gives me that radical 25. And, of course, that cleans up kind of nice. And what happens with my negative root 5 and my positive root 5? They cancel out, and that's going to happen every time when we multiply by the conjugate. So it's a pretty slick way to neaten things up here. So I have a -4 plus 4 root 5 in the numerator. And in the denominator, I have 1 minus, what's the square root of 25? Just 5. So 1 minus the 5 gives me? -4. You think we're done? We can simplify. There's a lot of 4s here. My favorite thing to do is this -4 is dividing both terms above. So this is my favorite way to simplify these things. That -4 has to divide both items above, both terms above. Wyatt, I don't know what you're doing, but it is not paying attention to me. It's kind of making me a little jealous. Thanks. Okay. All right. And so -4 divided by -4 is 1. And then here, my 4s are going to reduce, and what are we left with? Negative, yeah. It will be positive divided by negative is negative radical 5. And so that is what that simplifies to. Coincidentally, it is not always going to sort of just be the, I don't know, reverse of that. That is just a coincidence. Okay, so let's look at 24. Again, we're going to multiply by the conjugate of the denominator. So here's my denominator. What is the conjugate? Radical 5. Now, conjugate means to change. Minus 4. Yeah. So we're going to multiply top and bottom by radical 5 minus 4. And now we have to FOIL a ton of things together. So I'm going to do that here in the next line. So again, lots of FOILing here. 3 times radical 5, 3 radical 5. 3 times negative 4, negative 12. Radical 5 times radical 5, positive radical 25. And of course, you could simplify that if you wanted to, but I'm not going to. And then radical 5 times negative 4, negative 4 radical 5. Good. And again, that's just distributing the 3 and then distributing the radical 5. So down here, let's distribute the radical 5. Radical 5 times radical 5, radical 25. Radical 5 times negative 4, negative 4 radical 5. Distributing the 4, positive 4 radical 5, and 4 times negative 4. There we go. Negative 16, yeah. All right, a couple of things are going to clean up here. So I know that the square root of 25 is 5. And down here, the square root of 25 is 5. And look at the denominator, negative 4 root 5 and positive 4 root 5. 0. Okay. So again, we can sweeten that up a little bit here. In the numerator, 3 radical 5s minus 4 radical 5s is? Minus 1 radical 5, or just negative radical 5. Beautiful. And then we have a negative 12 and a positive 5. That gives me? Negative 7. The denominator, I have 5 minus 16, which is? Negative 11. Now, that's a whole lot of negatives. Yeah, so that is the nicest way, I think, the prettiest way to do it. It's the most elegant way. I can take out a negative 1 in the numerator, so that becomes radical 5 plus 7. I undistributed that negative 1. And then this is negative 11. Those will cancel out. Negative divided by negative is positive. And so we really do just get radical 5 plus 7 divided by 11. Could you go directly from all those negatives to all positives? Yeah. This is the elegant way to do it. That's it. Is that okay? Yeah? Sweet.
Do you have a delta math?
You do not today. I have a punchline. 18 minutes.